HVAC with Stephen Rardon is sponsored by TrueTech Tools. Quality tools, essential support. TrueTechTools.com.
Well, good morning, YouTube. It is Tuesday, November 17th, and I think one of my other videos I actually said it was... No, I think it's October. Yeah, I had screwed up the name on another video, probably. But October 17th, 2017, I am headed back to my favorite multi-zone Fujitsu mini split. I've got an error code on the control, and the system is either not heating or not cooling. I don't recall off the top of my head. Doesn't make a whole lot of difference whether it was heating or cooling problems, but to be honest, I'm a little scared to be taking on this responsibility personally. I've been to this house many times previously and have not been quite so nervous as I am on this one. So I will catch what I can as far as video goes, and we'll try to bring you along so you can witness the disaster that ensues. So stay tuned. This is the patient. We've got a Fujitsu AOU48 RLX FZ. We've got error 1 on the main board. So we're going to track down the meaning of such error. So error and a number, press enter button, press enter button. EA5.1 low pressure error. EA 5.1 low pressure error. I'm going to take the service valve covers off and see what we come up with. So standing pressure looks fine. So obviously, or apparently, it would appear that it is an operational pressure fault. So we're gonna see if we can figure that out, find out where the system fails when it runs, and then look at resolving the leak or pressure fault. So we finally got through the test run, and we've got PCL. Not 100% sure what that is, but we'll look it up and see if we can find a answer. I had to peel off of that diagnostic on the system because I had a prior engagement with this system checkup, and I'm supposed to be there at 2 o'clock, and it's going to take me an hour to get there, so I am going to be about 15 or 20 minutes behind. But I made contact with the customer to give them a heads up, and they said that that was okay. So we're gonna go over there and do that comprehensive system test, and then we'll come back over here, and hopefully by the time I come back I will have some kind of an answer on what exactly PCL means for the AOU48 condenser. Here's the layout for the other system. It is zoned, and it is a 4-ton unit zoned for a bonus room and then the main part of the house. So I'm going to start off by operating the heat. I've got both thermostats calling for heat, And I got my manifold kit set up, and we're gonna run it through its paces. Alright, we got high and low gas pressure ready to roll. This doesn't look like it's gonna work very well for holding the door switch. So this door switch doesn't want to cooperate. So we'll just put the door on. We got first stage at 1.78 inches of water with an inlet of 6.7. I'm not going to do combustion on this system, as it is not my unit, and it has caused trouble to have a test port in the vent piping when it comes to equipment inspections. So we'll just suffice to clock the meter and test the system in that manner. Total external right now is 0.16 inches. We're taking supply static pressure off of the end of the furnace and over here at the return box. Delta T temperature difference between return and supply right now, 74.5 and 89.6. Gives us a 15-degree temperature split. It is climbing a little bit, and I haven't looked into the wiring yet, but I believe this is going to be a second stage timeout, as the wiring on the zone board does not show W2. The zone board is capable of two-stage. They are using one of my favorite zone boards, which is the EcoJ Smart Zone. And they're also using a powered bypass, which is governed on pressure. It powers closed based on static pressure, which it takes from different points on the ducting. So the red light indicates that that zone damper is closed for the bypass. And it looks like they're only taking high side pressure into, which you can set it up either or, high or low side pressure to control the zone damper bypass. I'm gonna have to refresh my memory on how this unit stages up. So I'll be back in just a minute. So it looks like I'm gonna have to pull the door because I'm not able to find the manuals for this equipment to confirm. So we'll pull the door, which will shut the unit down under a warm operation, but don't have much choice. See if I can confirm the second stage operation procedure. Note 5 is about twinning furnaces. W2 delay, it's in the dip switches. So S1-1 and S1-2 shows on off for 10 minutes. S1-1, S1-2 are both off. And off is off. We'll go there and let's see what we got for available wires. We've got an orange wire that's available. We could bring into W2. thinking it should be available over there as well. So we'll go ahead and do that so that the system controls two-stage. The zone board will control two-stage demand or second stage demand. All right, so we got second stage enabled on the zone board. We'll fire it back up again. And second stage goes to 3.45 inches with an inlet of 6.3. Wait until the static pressure comes up as the system brings on a little bit more. 25.6 degree temperature split right now. 0.2 static, 0.275, 0.3, 0.36, 0.367. So a 0.4 static, just under a 0.4 static, is pretty darn good in heating, especially on a zone system. We got a 30 to 60 temperature rise, and we're running 32.6 currently, 32.8. I'm gonna go get ready to clock the meter. Alrighty. Well, while I was in the middle of trying to clock the meter, it dropped down to first stage, and the customer is concerned with how warm the house is getting. So we're going to go ahead and switch over to air conditioning. We're going to go through a bit of a delay on bringing on the cooling, but I do have the condenser turned off so we can play with airflow before we turn on the cooling and actually start bringing the home temperature down. Want to test static pressure and things like that. We got 0.418 static currently. Take total air handler amps for calculating performance. We got 6 amps on the air handler right now. Static seems to have balanced out at about 0.427. Return air static is just under 1.4 or 0.14 currently. At the moment, I'm satisfied with that operation on the air handler side. I'm going to head outside and take a look at the condenser. It's pretty straightforward. 14 SEER 410. Got discharge, suction, and liquid line temperatures, suction and liquid line pressures. Flip the breaker. And we're going to let it balance out for a little while before we worry too much about it. So the system was a little off on the subcooling, but all in all it was performing at 14 EER, which is a positive thing. Temperature differential was a little bit off because of it running a little lower subcooling, but all in all it is working pretty well. Can't fault it and complain a whole lot. That company does really clean work, so I can't fault them in that regard. I think I just missed my turn. Pretty sure I did. So I'm going to focus on driving, and we're going to head back over to that multi-zone mini split. The initial check going up through the louvers of the ceiling cassette was inconclusive. Didn't show anything that was indicative of any leakage. So I've pulled the frame down to see if I can maybe get something without the louvers, since it does limit access a little bit. I'll proceed to pull down the blower here once we give it a cursory sniff. I may be moving a little faster than maybe I should, but this leak detector has proven to be quite sensitive and has shown leaks fairly quickly. This is where the refrigerant piping connects to the unit, so I'm just going into that zone to see if I can get any kind of an indicator, and I've got nothing. So I'm going to pull the blower down, look at the inside of the coil, and go from there. From here, I'm going to pull down the drain pan. So we have some light flashing, which indicates that it believes it's sensing a refrigerant leak. But typically when it leaks, it will show lights all the way over and they'll turn red. So it could be a slow leak, but the TIF ZX has served me very well as a battery powered one-hand operation unit. I think we're probably going to have to pressure test it. There is a joint in here. Let's see if I can get some light. We've got what looks like somebody's attempt to split these open and leak search them. But we've got a joint here which was utilized one time when the system was leaking as a isolation point. Probably should have put isolation valves here as well as down in the crawl space, but I don't believe that we've got any leakage here. Oh well, so the battery on my leak detector decided to die, and there's other excuses I can make, but I'm not going to bother. But we're going to give it a fresh look tomorrow morning and see what we can figure out. They were ready to have me out of their house in one way, so at least where I was working in the downstairs with the 4 zones, So we're gonna come back in the morning and continue with the search for the leak. We are back at it. We're down in the basement. If this unit up here doesn't look familiar, you should probably go back and watch some other of my Fujitsu 5-zone videos. Upstairs was inconclusive, so we're gonna run through this one and see if we can get any hits. And that is a little bit disturbing that we've got that many lights just by going up the louver here. One thing about the unit we looked at earlier, or last night, that disturbs me with this unit is that the other system had much more rust on the coil than this one does, and it's supposed to be newer. But this coil is older than the one upstairs, and it's in much better condition than the other unit. Moved on to the other bedroom, and we got red lights immediately. More red lights. Alright, we're going to move on to the valves in the crawl space. There's 2 boxes with electronic expansion valves in them, and that's where the system has been prepared for isolation pressure testing. On the last repair, or one of the previous repairs, valves were put in to allow the systems to be isolated from each other. We used keep right valves, and we've got pressure taps on them. We got pressure taps here on these here, and then we've got ball valve caps here and there. When I bought the valves, they didn't have access fittings on them at that time. Some of them did, but they didn't have all the sizes that I needed with access fittings, so we put T's on them. Here we've got three. These two pipes here go up to the second floor, and then we've got these other ones here. So we got isolation valves that we can shut a valve down or shut a zone down. And then back here there are two Y fittings that split the refrigerant piping coming from the condenser. I didn't do this job, it wasn't my piping. I simply had to deal with what I had. Obviously tearing the insulation off would be a benefit once we get to a point, but at this moment I don't see the need to tear the insulation off of it. On this unit that has all the leaks in it, it appears that somebody stripped out the screw head. So that should be fun to try and figure out how to get this unit down with a stripped out screw. All of the mounting screws are behind this cover. So I guess I'm gonna fiddle with that and see if I can get it to back out. To initiate a recovery mode on this multi-zone mini split, the AOU48 by Fujitsu, you first start by pressing mode exit, which is the left button here. You push select until you see F3. You press the enter button, and then you push select until the LED on the left displays 21. On this unit it's 3 presses, and then you press enter for about 5 seconds. Done. Then you wait for the display to read P off, power off. Now we can turn off power to both the branch boxes and the main unit. The unit is sitting at 127 psi, 128, and by purging the hoses and then connecting the evacuated recovery tank, I was able to get just shy of a pound of refrigerant out of it. So we're going to fire up the recovery machine, the G5 Twin. And we'll check in when we get pulled down. Well, it is recovered down to a negative PSI on the gauge, and we've got about 4.5 pounds. And the kicker is that this unit holds nearly 12 pounds. So we definitely have a significant leak. My process from here is going to be to pressure test the air handlers and the refrigerant piping up to the air handlers and confirm which ones drop pressure over a period of time. I'm going to leave this pressure probe at the condenser and then add the other 2 high pressure probes for the circuit testing, so that I can monitor everything past the isolation valves, or from the isolation valves back to the condenser, as well as the other zones. But since there are 2 circuits here, I'm going to start with these. I'm going to put a pressure probe on each circuit and then isolate the valves and just use the pressure test that came from the condenser. Obviously I lost a couple of PSI there, maybe, and then there's a potential that I lost a couple of PSI there as well. We've got about 350 on each zone, so we're going to isolate and see which one falls. This first zone is the one that is in question with the electronic leak indication. The second one is the shop unit directly behind you. So now we're isolated. We're starting off at 355 for the shop unit and 350 for the other one, and the overall pressure test is 350. It's 9:51. We'll give this one several minutes. We're almost 10 minutes out, and the top one is the overall system, holding at about 350, 355 for the shop unit, and 345 for the bedroom unit that got the significant leak detector spikes. What I'm going to do next is pressurize that bedroom unit higher pressure as much as I have left in the tank, to see if I can hear or see the point of leakage at the air handler. Almost another 10 minutes later, the first 2 circuits are holding pressure nicely. I pushed the other one up to 425. That's what I ended up with after I pulled the hose off of the Schrader core, so that I wasn't adding another potential false leak. I'm not going to give that one a whole lot of time to confirm the leak, but I was unable to hear anything in the room. Too much ambient noise and other things going on to actually hear anything. It would have to be pretty loud. But from here, what I'm going to do is isolate that one circuit, or leave it isolated on the refrigerant piping, and then separate the electrical so that I can operate the system with the 4 air handlers that are not leaking.
So the circuit that had the 425 psi pressure test has dropped to 385 over the last, I'd say, 30 minutes or so. The rest of the circuit did not drop, but I'm in the process of evacuating the other circuits. We got the TES 8 vacuum running, and we're pulling down. It's kind of slow going, but it is going. We're looking at the Measure Quick app that uses the Blue Vac micron gauge, and we're a good ways from target, but we're making progress. I will probably leave this pump running for several hours, just due to the fact that I want to try to make sure that everything pulls down nicely. The beauty of the TES 8 vacuum pump is that you can do an oil change in a matter of seconds. You swap the oil cartridges and turn the pump back on. I've got the system under a vacuum. I want to try to get things as tight as possible. I was down to about 1100 microns, and the reason I'm not terribly worried about the fact that I'm down to 1100 microns after an hour or so, even with the large evacuation hoses, is because I know that this system has had several poor vacuums pulled on it previously. So there's a lot of contamination and whatnot in the system, or, you know, it's never been pulled down very low, so there's a lot of moisture in the refrigerant oil in the compressor and everything. As you can imagine, when 7 air handlers have been replaced, or 7 coils have been replaced on the system, it's had at least 7 evacuations or pseudo evacuations. So I'm going to let that run. I've got a couple of service calls that I need to get taken care of, and rather than sit there and babysit it, I'm just going to let it suck. And then we'll come back after we get these service calls. The service calls that I got to get to are on a couple of apartments, as I understand. They're in the same neighborhood, so I should be able to get both of them within a couple hours, but I've got to drive a couple of hours as well. So I will take you along on those if I can, and we'll get back to this one later this afternoon. It was difficult to get a perspective for the camera on these ones, but I think we got it pretty well figured out on the issues. The first unit appears to simply have a low refrigerant charge. There is some question as to why he was having issues with power input, but there's no indication as to any power issues at this point. System came on and had power at the blower, had power at the heat strips, everything was working as it should. On the second unit, the circuit board, or the blower control board, was burned out, and backfeeding power to the blower to run, as well as the heat strips. So the heat strips and the blower were running because of the burned out circuit board. Condenser definitely could stand to have a bit of a cleaning, but that's not within my purview at this moment. So I'm gonna head back over to that mini split and cross my fingers that that vacuum is well on its way, and we'll go from there. Oh my goodness gracious. It is 6 minutes after 5, and the vacuum will have been running for almost 6 hours now. So I'm gonna hop on over there and see where we're at. I'm gonna have to be happy with about 700 microns. It's still climbing at half a micron per second, but I'm out of time on this one, and it's getting down to 296 microns is the lowest that I know it's ever been to. So we're just gonna have to accept it as it is and hope for the best. The only method that I've been able to come up with to add refrigerant and minimize any air in the system when you don't have any charge in the compressor is to crack your ball valve on your process hose and get a little bit of refrigerant frost flowing, and then connect that hose and allow it to try to displace any oxygen that is in the system. So we're charging liquid, and we're taking it to 12 pounds, and we're going in on the liquid side. The system took 6 or 8 ounces before I was able to clear the scale, because I forgot to zero it out before I started adding. But anyway, we've got sufficient charge in it, so I'm going to see if I can get this powered back up and run through another check mode. After all is said and done, we're going to go ahead and recommission the system with another check run. I'm going to get my micron gauge out of the circuit here before I try to run it. The micron gauge is capable of handling pretty significant pressure, but I don't really want to give it a torture test, as you say. So that's done. To initiate a check run, we're going to hold down the check button for 5 seconds. It says we have 2 branch boxes, with the first number being 02, and 4 air handlers. From there, we're going to hold down the check run again for another 5 seconds. Now we're into check run, annotated by the word or the letter CRUN. I'm going to use the time that it starts running to pack up my junk, and we'll come back and hope to God that there's no issues with this check run operation. It looks like we are good to go. The last time it finished its check run, it gave me an error and a flashing red light. This time it just says end. So we're going to clear it out and get it back to operation and call it an evening. I wanted to thank you for watching. like, subscribe, comment, and share. Don't forget you can use coupon code RARDON at TrueTechTools.com to get 7% off your purchase. We'll see you on the next one. Peace.